7 inverse trig functions. So we are relying very heavily on our unit. So if you don't know your unit circle, you need to make sure that you have that memorized. So we're going to talk about today what it means. So an inverse function is a function that, number one, vertical line test and the horizontal line test. Okay, so passes vertical line test, horizontal line test. Our second thing about inverse functions, when we found before, so if we had something like y equals 4x, going ahead and we would swap our x and our y, so it would become x equals 4y plus 3. Sides, x minus 3 equals 4y. Function would be x minus 3 over 4. Okay, so that's really important to remember what an inverse function is. So the other thing to know about the inverse function is since the x's and y's swap places, the domain and range swap places. So our domain becomes our range, and our range becomes our domain. Okay? So an inverse sine function is defined by arc sine. So arc sine means the inverse function of sine. If and only if sine of y equals x. So it's just saying instead of sine of x equals y, we're saying sine of y equals x. Okay? So it's just backwards. Once again, that x and that y have swapped places. Okay? Both of these mean the same thing. They both mean inverse functions. Okay? So let's talk about our domain and our range. So this is a regular sine graph. Okay? So remember, our regular sine graph is periodic and it goes on forever and ever and ever. The problem is that it is not one-to-one. It does not pass the horizontal line test. So in order to make it one-to-one, what we're going to do is we're going to truncate it here so that we're only using the values 2 and pi over 2. Okay? So that is going to become our new range. Okay? It's our domain here, but that's going to become our new range. And our new domain, here our range is negative 1 to 1. So our new domain is going to become negative 1 to 1. Okay. So the reason we're restricted by the domain and range is because our function has to be 1 to 1. Okay. The other thing to look at is on the unit circle, my values repeat. So when I'm looking for an inverse sine, cosine, tangent, I'm given my x or y or y over x or x over y. Okay, so I'm given this value here, the coordinate. Okay. What I'm looking for is the angle measure. Okay. So I'm given the coordinate and I'm looking for the angle measure. But at pi over 4, sine is root 2 over 2. At 3 pi over 4, sine, so I'm just doing my y value here, sine is root 2 over 2. At 5 pi over 4, sine is root 2 over 2, negative. And over here at 7 pi over 4, my sine is negative root 2 over 2. So in order to encompass the whole unit circle, but make sure that it's 1 to 1 and it doesn't repeat, if we only go from negative pi over 2 to pi over 2, we'll get every single sine value in here. Because here we get all of our negative values for y, and here we get all of our positive values for y in that unit circle. Okay, so that's just some things that are really important to keep in mind. So now I'm going to turn the page and we're going to look at what an actual inverse sine graph looks like, and we're going to answer some questions or do some problems. So here is my inverse sine graph. Okay, so you can see that here my range is from negative pi over 2 to pi over 2, and my domain goes from negative 1 to 1. Okay, so it's just that portion of that sine graph on the last page that we looked at. So now we're going to come here to our arc sine. So remember, that's the same as inverse sine of negative 1/2. So what is this asking? So this is saying, what is the angle when y is negative 1/2? Okay, that's really what that says. I'm looking for the arc sine of negative 1/2. What's the angle measure when my y value on my axes equals 1/2? Okay, so if I look here, my y value is negative 1/2. Okay, I need to figure out, well, what is my x value? Okay, so how we're going to do that is we're going to go back to our unit circle. Okay, this graph you can use, but because of the scale and stuff, it's kind of hard to use it. So let's just go back to our unit circle. So the first question would be, in which quadrant is my sine value negative? Because we're looking for this negative. So if it's a negative, my y value is negative in this quadrant here, quadrant 4. So we know that it's going to be somewhere between negative pi over 2 to 0. And we're looking for a reference angle. So a reference angle is the distance from here to here, okay, or to where we end. Okay, so now where is my y value 1/2? And you can either use your hand trick or think back to your unit circle. And we have that sine is 1/2 at, I'm going to use my hand trick here, at pi over 6. Okay, so that's going to be negative pi over 6 because we're going here in the negative direction. Okay, and remember, it has to be between negative pi over 2 and pi over 2. So I can't do 11 pi over 6 here because that's bigger than pi over 2. It's not in my domain. Okay, so my answer is negative pi over 6. So now let's take a look at sine of root 3 over 2. So the first thing I know is sine is positive. Okay, so for sine, I'm only going from here to here. So I know if it's positive, my y value is positive there. And square roots of 3 over 2. Okay, so where is my y value, root 3 over 2? It's at pi over 3. So that's my answer. And then this last one says the inverse sine at 2. So where is my y value in my unit circle? 2. Well, that's outside of my domain. My y value is never 2 on my unit circle. So that's going to be no solution or no real solutions. It's outside of my domain. Okay. So we can write outside the domain. And so now we're going to look at, we're just going to recap sine, and then we're going to take a quick look at cosine and tangent. They work the same way, but they're just slightly different as far as the range on each of them go, or the range on cosine anyways. All right, so for arc sine, we're only going to use negative pi over 2. Okay, so we're either going this way, or we're going to go up here to pi over 2. We don't ever use any of that, okay, for our unit circle. So our domain is negative 1 to 1, okay, because our y value down here is negative 1, and our y value up here is positive 1, and we can use everything between. Now let's look at our cosine function. So our cosine function, if I sketch my cosine graph here, it starts up here, it comes down, and then it comes back up. So in order to make it a one-to-one function, I'm going to have to stop it just like I did my sine graph. So for this one, I'm going to start at 0 and go to pi. Right? And if we're looking at our unit circle, okay, if I started down here and went to here, my x values are all positive here. My x values are all positive here, so that wouldn't work. So for cosine, our range is going to be 0 to pi. Our domain is the same, okay, because here we have an x value of 1, and here we have an x value of -1. Okay, so our domain is still -1 to 1. Okay, but our range, we're only going to use values between 0 and pi. Okay, we never, ever use this. And then take a look at tangent as well. So our tangent function, okay, our basic tangent graph, starts at -pi/2 and goes to pi/2 and goes up this way. Okay, so if we take the inverse of that, our domain and range are going to flop. So here our range was -infinity to infinity, so our new domain is -infinity to infinity. And our range for one period of it, or I guess one period, is pi, and it goes from -pi/2 to pi/2. Okay, so the cool thing is tangent looks exactly like sine. So if we're looking at our unit circle, we're going either to -pi/2 or we're going to +pi/2. Okay, but now for tangent, we're looking for that y/x value, right? That's our tangent. Okay. So using this information, let's go on ahead and answer a few problems. So this one says arc cosine of √2/2. So since it's arc cosine, we're going to be using our values from 0 to pi. It's a positive value, so it's not going to be here. So we know it's going to be over here. And now we need to find where is our x value. So where is x √2/2? That's what it's asking us. Okay, so x is √2/2 at pi/4. So that's our answer. Same thing here, arc cosine of -1. For arc cosine of -1, we're saying we're using cosine. So it's from 0 to pi. And we want to know where is x -1. Well, x is -1 right here at -1, 0. Okay, so the answer is pi. Arc tangent of 0. So now we're looking for a spot where y/x equals 0. Which means our y value has to equal 0. So if our y value equals 0, well, here is 0, -1, here's 1, 0, and here's 0, 1. It's going to be this spot right here, which is between -pi/2 and pi/2, so it has to be 0. We can't call it 2 pi because that's outside of this range of -pi/2 to pi/2. And then when is arc tangent -1? Okay. So here's where it really is good to learn your hand trick. Otherwise, you have to kind of memorize your tangent. So tangent of -1 isn't so bad. So when we're using our hand trick, we usually have our fingers this way. But let's go on ahead and flip our hand over. Okay. And if it's -1, we need the same number of fingers on top and bottom. Okay. So if I put my middle finger down here, then I have 2 fingers on top and 2 on bottom. And this is how you're going to do it because you're going to be looking at it up with your thumb down. Okay, then we can turn it over, okay, and we can see that it's really our third finger. So 1, 2, 3, so that's going to be pi over 4. Okay, but pi over 4 is always going to be tangent equals 1 or negative 1. So we know it's pi over 4, but now we have to decide if it's pi over 4 or negative pi over 4. Well, since it's negative 1, our tangent is negative in the fourth quadrant. So our answer then is going to be negative pi over 4. That's where our tangent, or y over x, equals negative 1. Is last one say use a calculator to approximate the value, if possible. So the very first thing is we need to make sure that our mode is in radians. Okay, these are not degrees. They don't have any degree symbols on them. And now we're just going to plug that in. Okay, so to do arctangent, okay, remember that that is the same thing as tan negative 1 of negative 8.45. So now we're going to do secant and tangent to get our inverse tangent. Then we're going to do negative 8.45. Make sure that you did the negative sign and not the minus sign. Hit enter and you get negative 1.453. All right, let's go on ahead and do arc sine of 0.2447. So same thing, we're going to do the inverse sine, so secant sine, and then we're going to do 0.2447, and we get 0.2472. Okay, so these are approximate. These are no longer exact. Okay, so on this one we were finding the exact value based off of the unit circle, and this one we're approximating. And this last one says find arc cosine of 2. Well, what is our domain for cosine? Our domain goes from negative 1 to 1. So 2 is not in our domain, which means there is going to be no real solution to this answer, this problem. Have a great day. Ask questions if you have them. And I'll see you all next time.